So let's discuss a question on strength of material. So basically a composite, composite, or I should say a stepped shaft kind of a thing is given, where you have on the left side the aluminium shaft and then the steel shaft, which is just on the right side of aluminum, and we have a load actually at various points that is shown in the figure. The modulus of elasticity, the cross section, everything is given. So now the thing is, we need to find out the maximum principal stress in this component. Now remember that because it's a uniaxial loading, and for a uniaxial loading the maximum principal stress is nothing but the max tensile stress. Maximum principal stress is nothing but the max tensile stress, because you have a uniaxial loading, and so whatever is max, that is the principal stress. The principal stress is nothing but the maximum normal stresses in all the directions. So if you are applying loading in one direction, and that the normal the face, that face will be principal plane where you are applying, so that will be the max loading. So max tensile loading, so max tensile stress actually I should say. Okay, so what we will do is, because the loads are applied at different points, so we don't know where the max will come, so we will compute stress in aluminum, will compute stress in steel, and out of those two, whichever is maximum, that is declared as the winner. So stress in the steel, we have to see this steel bar and what is the loading on it. So if you take a cross section, okay, and right side, if you take, the load is 200 kilonewtons, so on this cross section the resistance is also 200 kilonewtons. So this resistance by area is what is, so load you are getting on the cross section, so that is the resistance force, that by area is the stress. So 200 kilonewtons, so into 10 power 3 by area of cross section of the steel. So area of cross section of steel is 30, so pi by 4 d square, so 30 whole square. So this, when I compute, I am using the numerator is in Newton and denominator is mm square. So this value comes out to be 282.9 MPa. Okay, so this was steel. Now coming to the aluminum. Now if I take a cross section here, the total load on the right side is 400 kilonewtons. So load coming on this cross section is 400 kilonewtons. So same thing, load by area, so 400 into 10 power 3 is the load, by pi by 4 d square, which is again 50 whole square. Area cross section is 50. So this value comes out to be 203.7. I mean, you would have expected, because of the more load you will get more stress, but because the area increase, the stress is less. So the answer out of these two, the maximum is 282, which is close to 283. I mean, if you round it off, so 283 is the maximum stress in the component, because you have to compare everything and whichever is the maximum that you have to say. So 283 MPa in steel. Thank you.